Okay, so now today we are going to talk about the some of these reconciliations of these the Legendre polynomials. So, in the previous lecture, we have actually started with this reconciliation, and we have done one of the reconciliation. If you remember, that particular reconciliation was like uh, some 2n plus 1, right? Hope you remember that x pn of x is equal to some n plus 1 n plus 1 p n plus 1 of x plus n p n minus 1 of x. Okay, we have already proved this, right? Similarly, we have few more reconciliation, and we also need to prove these reconciliation because they are very useful while we are dealing with the Legendre polynomials, because we need to have the Legendre polynomials of the different orders, and we can use all these reconciliation to solve some of the physical problems which appear in the physics. Okay, so now let us start with the second one. The second one is we have to prove that x pn prime of x pn prime of x is equal to uh, not is equal to minus pn minus 1 prime of x. This is equal to n pn of x. Actually, all these relations are very simple. You can see, again we will start here with the RD, which we know, the generating function. See, so you will see, since which like we did in this case, we start with the generating function, then we take the differentiation with respect to it, then after rearranging the terms we arrive at this particular reconciliation. Similarly, so we can also, since we know that the generating function, the function we generate is a Legendre polynomials of order n, is always given. There is this function 1 minus 2xh plus h square raised to power minus 1 by 2. It generates a Legendre polynomials like summation h raised to power n p n of x, right? So this is generating function, and it generates a Legendre polynomial. This also we have proved in the previous class. Okay. Okay, so now see what I will do. Again, I will just start with the differentiating this particular equation with respect to the h. Now, differentiating with respect to h. So when we are differentiating this with respect to h, you can say that this is 1 minus 2, 1 minus 2xh plus h square raised to power minus 1, 3 by 2, 1 n minus 1, that is minus 1 by 2 minus 1, that is 3 by 2, into the differentiation of this part. So that is minus 2x plus 2h. Differentiation of this is 2h, and the differentiation of this is 2x, and differentiation of this is 2h. Okay, fine. So this is actually equal to summation over n. Now n into h raised to power n minus 1 pn of x, right? So pn of x will serve as a constant because it is independent of h. Okay, fine. So now what is the next step? Now what I will do, I will again integrate this equation. So you can also name this as equation. Now I will differentiate it with respect to x. With respect to x. You can also name this as equation 1, this as equation 2. Differentiating equation 1 with respect to x now. So when you are going to differentiate it with respect to x, this is a function of x. So it will be again minus 1 by 2, 1 minus 2xh plus h square raised to power minus 3 by 2. Okay. Now with respect to x, so this is will serve as a constant. This is constant, so only this part will remain. So 2x is minus 2h will now be equal to, so it is summation over n, h raised to power n will remain as such, and pn of x, it's pn prime of x. Name this as equation 3. Okay. Now what I will do, I will just divide this equation 2 by equation 3. Divide equation 2 by 3. So when you are going to divide it, see, you can see I'm not going to write these terms. This term and this term will cancel out. You will be left with 2. Will just, you can take 2 out here, और यहाँ पे ये है. So you will write down simply this as minus x plus h divided by this is h will be equal to, now this is summation n h raised to power n minus 1 pn of x divided by summation over n h raised to power n Pn prime of x. Okay, so it's very simple. This relation is very simple. Now see, I can just multiply this to this and this to this and see we will arrive at this which we are supposed to find out. Okay, so I will write it here. So see, I can write down this as minus x से multiply करिए minus summation over n x h raised to power n p n prime of x, right? Okay, plus summation over n, when you will multiply it with h, it will h raised to power n plus 1 h plus n h raised to power n plus 1 p n prime of x p n prime of x. This will be equal to, now this will be summation over n, so this is n h raised to power n h raised to power n Pn of x, right? Okay, this is an equation. Now, like in the previous case, in this example, we can equate the coefficient of h raised to power n. But before equating the coefficient of h raised to power n, we will make the coefficient equal to h raised to power n throughout. What does it mean? Here it is h raised to power n. We are okay with it. It is h raised to power n. It is h raised to power n plus 1. To make it h raised to power n, we will just substitute n equal to n minus 1, right? So on equating the coefficient of h raised to power n on both sides, you can see equating coefficient of h raised to power n, right? On both sides, we have what we have. So you can say that we can write down this as minus x coefficient of h raised to power n, खाली मुझे लिखना n minus x p n prime of x will plus, okay, now to make it n equal to n minus 1, so it will be h raised, it will become h, so this will become plus p n minus 1, because I'm substituting n equal to n minus 1. P n minus 1 prime of x will now be equal to, okay, here I can see that this is n p n of x, n p n of x, right? uh, I think it should be minus here. It should be minus. This is minus. So when you are going to multiply it, it will again become minus here. This is minus 2ich. So this is minus. So this is minus np. Now here I can take the minus sign out and cancel out with this minus. We can say this is x pn prime of x minus Pn minus 1 prime of x will be equal to n Pn of x. This minus and minus term will cancel out. Now see, if you'll just see, look at this equation, this is what we were supposed to prove. यहाँ पे x Pn prime of x minus Pn minus 1 prime of x, this is equal to n Pn of x. I hope this is okay. Is it okay? This is very simple. Just we are taking the generating function, right? This we already know. Then we differentiate it with respect to h, then differentiate with respect to x, divide this by this equation by this equation, just rearrange the terms, equate the coefficient of h raised power n, and you will get this result. Is it okay?
Yes, sir.
Yes, sir.
Okay, thank you. Chalo, fine. So okay, if this is okay, then I can move to the second one, or rather third one. Okay. Now similarly, uh, third one. So the third one is like I have Pn prime of x minus x Pn minus 1 prime of x is equal to n Pn minus 1 of x. Okay, this is the third, and we have to prove this. Now see, uh, we can just prove it by using these the first and the second reconciliation, which we already have proved that. Okay, now before I will just write down the first reconciliation, since we know the first from the we know from first relation. First relation means first reconciliation. What we know from that? We know that 2n plus 1 xpn of x xpn of x is equal to n plus 1 pn of pn plus 1 of x plus n pn minus 1 of x, right? Okay, this is the we have already proven. Now what I will do, I will just take n equal to n minus 1. Okay? Put n equal to n minus 1. What will this relation become? N equal to n, it will become 2n minus 2 plus 1. So it will simply become 2n minus 1 x p n minus 1 of x, because I'm substituting n throughout, n equal to n minus 1. This will become is equal to n into n minus 1 plus 1 n minus 1. It will become n p n of x plus now n minus 1 p n minus 2 of x. Just try to understand, it's very simple and I'm making it more simple. Okay, now to this relation, now I'm going to differentiate with respect to x. So when you are going to
अरे टू एन
differentiate,
प्लस वन है ना इसमें, एन जब पुट
Two
करेंगे एन
and
माइनस वन, वन
one
वन
and
कैंसिल होगा तो खाली टू एन बचेगा वहां पे.
one आएगा.
नहीं यार क्या हुआ
वहाँ
तुम्हें,
पे
this
टू
is
है ना मल्टीपल है ना.
2n minus 1, this will become 2n minus 2 plus 1.
हमने ब्रैकेट में लिखा था.
हाँ, n हमें
तो
देना
ऐसे
है ना.
फिर कहीं लिखूं टू एन प्लस वन, ये शो मल्टीपल ऑफ सर से नेबर कहीं.
क्या हुआ बुरहान? This is 2n minus 1 and you are going to substitute n minus 1,
ठीक, ओके 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 सर, ठीक
differentiating with respect to x. So when you are going to differentiate it with respect to x, this is constant. I will write down this as 2n minus 1. Now these are two terms. I will just u into v rule. So I will just take the differentiation of this part, take the differentiation of this part. Uh, just 1 minute. Okay. So I will write down this as p n minus 1 of x into differentiation of x, that is 1 plus 2n minus 1 into x. I will write as now the differentiation of this will become p n minus 1 prime of x. Similarly, this will be equal to n p n prime of x plus n minus 1 p n minus 2 prime of x. Simply I just differentiate it, only this will remain as such. This is a function of x, only the different, and this is a constant. Here we are going to take u into v. First I am going to do differentiation of this into the differentiation of x, then the x into the differentiation of this. Okay, fine. Now what I will do, I will just rearrange again these terms. See what I will do, I will just write this equation, these three equations as, I will just n, see this part, n into pn prime of x, right? N into pn prime of x plus, now what I will do, I will write down this as n minus 1, n minus 1 p prime n minus 2 of x. यहाँ पे अंडरस्टैंड कीजिएगा ये, सॉरी. Okay, this is okay. This term n pn of x, or ye n, this is I'm doing it for a reason, because you will see now n pn of x. Now here I'm going to write it not plus, it is minus this x into p n minus 1 prime of x. Now you will see we don't have n n here ना, xpn of price. This is n into xpn of, यहाँ पे मैं लिख रहा हूँ, this is minus n xpn minus 1 prime of x, ये term जो यहाँ पे. So what is left here, we are left with another minus n xpn minus 1 prime of x, and when you will add these two, it will become 2 minus 2n xpn minus 1 prime of x. So this is 2n x pn minus 1, then is another term, so that I'm going to write it here. Okay, minus, now n minus 1, n minus 1, n minus 1 I'm going to take common again. Now I am going to write it as x into pn minus 1 prime again, pn minus 1 prime this Pn minus 1 prime n minus 1. Okay, minus n minus 1 is common here, so this is Pn minus 2 prime of x. Okay, this will be equal to this thing. ये term चली गई, ये भी खत्म, ये भी खत्म. और we are left with 2n minus, this will be equal to 2n minus 1 p n minus 1 prime of x. See, now above, so it's, why I'm doing it this is again I'm saying I did it for a reason, because I already have proved this kind of a reconciliation, so I can just use that reconciliation to prove that this particular reconciliation. That's why I put it like this. So see, यहाँ पे ये है, this is n pn of prime of x यहाँ पे minus x pn minus 1. So this we are left with यहाँ पे असल में ये 2n x pn minus 1, so plus 2n minus 1, right? But I write it as minus, यहाँ पे आप देखिएगा, this will become minus n x pn minus 1 prime up. So this minus and this minus, it will be twice x pn minus 1 prime of x, right? So that's why I write it separately. इसको understand करिएगा. This part I am just breaking it into two different parts. Then I have minus 1 into x pn of n minus 1 into x pn of pn minus 1, वो मैंने यहाँ पे लिखा है. Only this x pn prime part जो है यहाँ पे, उसको I just split it into two parts, right? Fine. So why I'm doing doing this, because you know that from the previous reconciliation, since we know that, since from the reconciliation second, I guess, since अभी जो मैंने किया x pn prime of x since x pn prime of x minus pn minus 1 prime of x is equal to npn. Relation second जो हमने अभी प्रूव की है, relation second. That's why I put it in this form, right? Okay, so then what I can do, I will just write this equation as, this is first what I will do, I will just rewrite this equation as, so I can write down this as equation as n pn prime of, sorry, pn prime of x minus x pn minus 1 prime of x. Okay, this equation, this part I'm going to write it as a minus n minus 1. Okay, now what is x pn minus 1 prime? X pn minus 1 prime minus pn minus 2 prime. Now if you will substitute here pn equal to n minus 1 in this reconciliation, so you will say that this is x pn minus 1 prime of x minus pn minus 2 prime of x will be equal to n pn, sorry, it will be n minus 1 into pn minus 1
N
from
minus
this
1
reconciliation,
Pn minus 1.
pn minus 1. So then you can say this relation, so this part pn minus 2, I can simply write down this as n minus 1 into pn minus 1, right? Pn minus 1 of x also you can write down. This is equal to 1. This is equal to 2n minus 1 pn minus 1 of x. Okay, fine. So now see, I just further rearrange it. I can write down this equation as n pn prime of x minus x p prime n minus 1 of x. This is as such, I'm just writing it as such, minus this will become n minus 1 square minus then this 2n minus 1, इसको मैं यहाँ पे ले लूंगा, this 2n minus 1 into pn minus 1, because pn minus 1 this is a common factor, pn minus 1 यहाँ पे भी है आपका और p minus 1 यहाँ पे भी है आपका. Okay, so see this part in this bracket, you can say this is like, अगर आप इसको थोड़ा expand करोगे, it will be now, यहाँ पे लिख लूँ मैं पहले, या see again, oh sorry, I can write it here. अगर आप यहाँ देखोगे, this will be n square minus 2n minus 2n plus 1 plus 1. There is some ये प्लस होना चाहिए यहाँ पे. This should be a plus here. This should be plus here. Huh. This is plus because this is plus because I am taking minus बाहर term sign में लिख रहा हूँ. That's why. ठीक है. So now this will become n square minus 2n plus 1 plus 2n minus 1 is there. This minus 1 plus 1 2n, they will cancel out and we will be left with only n square, right? So this will become n square. This is, you can write it as a 0. I don't need to write it 0. I can also write it like equal to this. Okay, but फिलहाल क्योंकि मैंने इसको यहाँ पे लिया है, you can write it equal to 0. Okay, so now when I'm so this reconciliation I can again write it like, so you just write it again, n pn prime of x minus x pn minus 1 prime of x. Okay. Okay, let us take this to now the right hand side. This will be equal to n square p n minus 1 of x. जो मैं 0 यहाँ पे कह रहा था, I'm just taking it because ये minus n square है यहाँ पे, n into minus 1. और so this n, one n will get cancelled out with the square, one n. So you will see that p n prime of x minus x p n minus 1 prime of x will be equal to n p n minus 1 of x. So I guess this is the reconciliation. यहाँ पे देखिए p n prime of x minus x p n minus 1 prime of n p n minus 1. So this is what we were supposed to prove. Is it okay, or you have any doubt? If you have any doubt here in understanding any step, you can ask. Okay, so if it's okay, then let us move to the another one. Okay, one last one, then I will give you two as an assignment. You can prove those two from this, from these all these reconciliation, right? Okay. Again, now what I will do, what is the another one? This was the third, and similarly I have the next one, that is fourth. This is pn plus 1 prime of x minus pn minus 1 prime of x, n minus 1 prime of x. This will be equal to 2n plus 1 pn of x. If you go through the book Arafkin, you cannot find them solved there. Okay? So the reconciliations are put there in the book, but they are not solved there. So to solve these equations, you can go through some other text like we have. I just saw these reconciliations have been solved on the book. This H.K. Das, he has also solved these reconciliation. Otherwise, in Arafkin and some other books, you cannot find these books, these reconciliations as elaborate, solved in that particular elaborated way, right? Okay, so now this is again what I will do. I will just consider the reconciliation. Which reconciliation? From the if you look, if you are writing it on the board, just tell me the third reconciliation क्या था आपका, sorry, the third one, जो third one अभी हमने reconciliation लिखा था क्या था वो. So you don't need to tell me, I will just tell you what it is.
N prime minus
No, sorry, not third one. I will just first write, then I will tell you what I mean. From the third one, from the first one, from the first one, the in which we substitute n equal to n minus 1, जो मैंने अभी किया था, and when I substitute n equal to n minus 1, the reconciliation becomes 2n minus 1. Let me write that first again. Uh, 2n minus 1 from the reconciliation thought जहां पे मैंने अभी कहा था you can substitute n equal to n minus 1. So this is 2n minus 1 x p n minus 1 of x. is equal to n Pn of x plus n minus 1 Pn minus 2 of x. ये था n minus 1. Fine. This reconciliation. See, since we have proved this just in a while ago, this is what we get this from the reconciliation first. So ये याद रखिएगा, from first by putting or by making by putting n equal to n minus 1, we get this. Now I will just rearrange it a little bit. I will write down this reconciliation as n Pn of x will be equal to, this thing will be equal to 2n minus 1 of x Pn minus 1 of x minus n minus 1, this side I'm taking Pn minus 2 of x, right? Now what I will do, I will just replace n by n plus 1. When you are going to replace n by n plus 1, this will become n plus 1 Pn plus 1 of x, right? This will become 2n plus 1 x Pn of x minus n Pn minus 1 of x, right? Just replace n by n plus 1. So this, from this relation you will just get this particular thing, right? Okay. Now now again I am going to differentiate with respect to x. Now differentiate with respect to x. Okay, so when you are going to differentiate this particular equation with respect to x, you will write down this simply as n plus 1 p n plus 1 prime of x will be equal to, now 2n plus 1, एक में आपका pn of x आएगा, differentiation of x is 1 plus, sorry, 2n plus 1 then x Pn prime of x minus n into Pn minus 1 prime of x. Okay, now again also we know that, what we know, since we know that x Pn prime of x minus Pn minus 1 prime of x, reconciliation third, this is equal to n Pn of x. Not third, but I guess first one, second, sorry, n Pn of x, second one. यहाँ पे लिखिएगा from relation second. Okay. So now what I will do, I will just rewrite this equation as, or this relation I can write down this as x Pn prime of x will be equal to, just take this as n Pn of x plus this side, this is Pn minus 1 prime of x. Right? Okay. So now then what will this x Pn prime of x के बदले हम क्या लिखेंगे यहाँ पे? So I can write down this is n plus 1, this relation, therefore this particular relation will become n plus 1 Pn plus 1 prime of x will be equal to, shabash, 2n plus 1, this is what I'm going to write as such, 2n plus 1 Pn of x plus 2n plus 1 x. Okay, now 2n plus 1, now x Pn prime of x, what is x Pn prime of x, यहाँ पे मैं substitute करूंगा x Pn prime of x, it will be n Pn of x plus Pn minus 1 prime of x minus n Pn minus 1 prime of x. Okay, now you can just again simplify these things, you can just simplify it a little bit. Now you don't need this, I will write it here as a writing on the next page. Okay, See, so now just simply I will just going to rearrange these terms. Pn plus 1 prime, so n plus 1, Pn plus 1 यहाँ पे है कोई n plus 1. I will write down this as simply n plus 1 Pn plus 1 prime of x. यहाँ पे this is 2n plus 1 and 2n minus 1 Pn of x.
plus
Pn
1.
minus, sorry, wait.
Repeat,
I will just
repeat.
एक second. I will write down this as 2n plus, sorry, 2n plus 1 Pn of x, 2n plus 1 Pn of x plus this is 2n plus
2n
2n
plus 1.
plus 1 n Pn of x plus, now this is 2n plus 1 minus n into Pn minus 1 prime of x. यहाँ पे this is 2n minus 1 और यहाँ पे ये minus n है, दोनों का ये Pn minus 1 prime है. Okay, so now what I will do, this is n my n plus 1, so I will write down this as simply n plus 1 टर्म में कॉमन लूंगा इन दोनों में, n plus 1 Pn plus 1 prime, Pn plus 1 prime of x minus when I'm Pn minus 1 prime of x. Okay, this will be equal to, इसको जरा सा 2n plus 1 prime of x and 2n plus 1 into n Pn of x. So this will be now 2n plus 1 कॉमन आपका आ जाएगा यहाँ पे 2n plus 1 no 2n plus 1 Pn of x. इसको थोड़ा सा सिंप्लीफाई करना है यहाँ पे. This will become 2n plus 1 3n plus Pn. Okay, now this simply should become, one of them should be minus, I guess. 2n plus 1 Pn of x, इसको जरा चेक करेंगे. 2n plus 1 Pn of x. Yes, this is 2n minus 1 Pn of x यहाँ पे. This is 2n minus 1, that's why ये थोड़ा problem create. So this is 2n plus 1 and one another is 2n minus 1. So when you are going to do 2n plus 1 Pnx, 2n plus 1 minus n, it will simply become n plus 1 Pn of x, right? यहाँ पे 2n plus Pn x just 2n, it will become n plus 1. It will become n plus 1. 2n plus 1. No. It should become n plus 1 Pn of x. This is not 2n minus 1. This is 2n plus 1 here. नहीं लिखा है गलत यहाँ पे. This is 2n plus 1. So 2n plus 1 will get found. ये simple है यार. This is 2n plus 1 Pn of x. But we have again n here, na? This is 2n plus 1 Pn of x. Okay, yes, this is n plus 1. फिर यहाँ पे आपका हो जाएगा. So this will become 2n plus 1 Pn of x. One is 2n plus 1 of x, and the other will become n into Pn of x. So this will be n plus 1. So this will now become 2n plus 1. 2n plus 1. Simply 2n plus 1 Pn of x में इन दो टर्म्स में कॉमन ले रहा हूँ. तो यहाँ पे आपका क्या बच जाएगा? यहाँ पे आपका सिंपली कॉमन रह जाएगा. एक में आपका 1 रह जाएगा. 1 plus n. 1 plus n. Right, now this 1 plus n will cancel out with this n plus 1, so we will be left with Pn plus